Hi, in this video, we'll explore a different method of writing the null and alternative hypothesis. So in the previous video, we talked about what I consider to be the slightly more traditional method. So the original method that we talked about was, suppose we have an alternative hypothesis that the true mean is greater than 50. Then the null hypothesis is going to have the same number, but it always has an equal to sign. So the null hypothesis would be the true mean equals 50. An alternative way of doing the null and alternative hypothesis is you always have HO, the null hypothesis, and HA, the alternative hypothesis, being complements of each other. So for example, if the true mean is greater than 50, that would be, because it's a strict inequality, that would be under HA. The null hypothesis would be the complement of that. So if you think of a number line here, if we're saying, let's say this is 50 on the number line, if we're saying the alternative hypothesis is that the mean has to be bigger than 50, then everything else would be covered under the null hypothesis. So that would include every number below 50, but also equal to 50. So the null hypothesis would be that the true mean is less than or equal to 50. So just like before, the alternative hypothesis is always what's called a strict inequality. There's never an equal to part on it. However, unlike before, the null hypothesis is just always going to be the complement, everything else that's not included in the alternative. All right, so just to review, here's some terminology. If we have a word problem that says greater than, or it says more than, or exceeds, or above, we use the greater than symbol. We use the symbol right here. If it says at least, no less than, no fewer than, or at a minimum it's this, or it says greater than or equal to some number, we're going to use this greater than or equal to symbol. Because the greater than symbol does not have an equal to component, this would be a strict inequality, which means it must be part of HA. If we have a greater than or equal to system, because there's an equal to part on it, it's going to be HO. That's where we'd put that. All right, if we have a less than symbol, meaning that we have some keywords in problems such that less than, fewer than, below, under, something like that, we're going to use the less than symbol. And that's going to go under HA because it's a strict inequality. And making sure I get that right, yeah. And if it's a less than or equal to sign, or maybe some keywords might be that some number is at most, or no more than, or not exceeds, does not exceed, or as at a maximum some number, we're going to use the less than or equal to sign, which because there's an equal to part, it's going to go under HO. And the third scenario is if we have equal to or not equal to, and I really kind of flip these, the equal to clearly would go under HO because it has the equal to part on it. Some keywords might be something like the mean is some number, or the mean is the same as something. Not equal to, keywords would be not equal to, differs, is not. And we would put this under HA because, again, there's clearly not an equal to part in here. That's literally what it's saying. It's not equal to this. So it's a strict inequality, so it goes under HA. All right, so let's do a couple of examples. So in this example here, it says that it's believed that the true average weight of a 9.6 ounce cereal box is less than 9.6 ounces. So let's write the null and alternative hypothesis. So we're talking about average weight. So the parameter we would use to test that is mu, the population mean. And so putting this in symbols, we're saying the true mean, mu, is less than 9.6. So would this go under HO or HA? Remember, HO always has an equal to part, and HA is always a strict inequality. All right, so hopefully you thought about this for a moment. Because of the less than symbol, that is a strict inequality. So that's going to be part of HA, the alternative hypothesis. So writing this out in symbols, our claim is that the true mean is less than 9.6 ounces. That's the claim. And the alternative to that would be everything else. So we would say the true mean is greater than or equal to 9.6 ounces. All right, let's do one more. In this one, it says, let's test the claim that no more than half the population can touch their toes without straining. Write the null and alternative hypothesis. All right, so the parameter is not mentioned explicitly, but what's being described here when we say no more than half the population can do something, we're saying that the true proportion of people, so we'll write this as P, because that's the population proportion is P, no more than half. So no more than, let's look at our symbols here. No more than is over here. So the symbol we would use is a less than or equal to sign. All right, so we're going to write P is less than or equal to 1/2 or 0.5. All right, so would this go under HO or HA? Take a moment to think about that. All right, so because the symbol here, this less than or equal to symbol has an equal to component, it's going to go under the null hypothesis, under HO. So therefore, our claim is that P is less than or equal to 0.5. And I'll label this is the actual claim. And the alternative would be everything else. So everything else would be that P is greater than 0.5. All right, I hope that clears some things up. Both methods, method 1 and method 2, are perfectly valid methods. In your homework and on the exams, we'll be using method 2 for this semester. That's what your book uses, so that's what we'll be using. There's nothing wrong with method 2. There's nothing wrong with method 1. They're just different ways of expressing really the same idea. All right, have a good one. And of course, let me know if you have any questions.